friends, in thermodynamics, already we discussed about the Carnot engine and we derived the equation of the efficiency of a Carnot engine. Now, today we are going to discuss about the coefficient of performance of a Carnot engine. What is the equation of the alpha? That means the coefficient of performance of a Carnot engine. For that purpose, first we revise the definition of efficiency and definition of coefficient of performance. Now, the efficiency of a cyclic process already we define in case of a heat engine. The ratio of the net work done to the total amount of energy absorbed. That means the W upon Q1. That is known as the efficiency. Already we obtained this. N is equal to W upon Q1. And also, how much work is done? In case of a heat engine, Q1 amount of the heat is absorbed. As a result, work done by the gas. That means the system is expanded and Q2 amount of the heat is released. Therefore, net work done is equal to Q1 minus Q2. So we substitute here, therefore Q1 minus Q2 upon Q1. So our equation becomes efficiency is equal to 1 upon Q2, 1 minus Q2 upon Q1. And in case of a refrigerator, we obtain the performance of coefficient alpha. Would either process, cyclic process, take place in heat engine if this process are reversed? So there is the working of a refrigerator. In case of a refrigerator, Q2 amount of the heat is absorbed. To absorb this heat, the work done on a working system, and Q1 amount of the heat is released. Therefore, the definition of coefficient of performance is that the ratio of the total amount of the heat absorbed, released to the work done on a system. That means the Q1 upon W. Here also W is equal to Q1 minus Q2. W is equal to Q1 minus Q2. So as a result, Q1 upon Q1 minus Q2. There is the equation of coefficient of performance. We are using these two equations to derive the equation of coefficient of performance of a Carnot engine. Right? Okay. Now, the efficiency in case of a cyclic process and efficiency of cyclic process, equation is N is equal to 1 minus Q2 upon Q1. That is your equation 1. And efficiency of a Carnot engine, that is depends on the temperature and efficiency of a Carnot engine N is equal to 1 minus T2 upon T1, equation number 2. From equation 1 and 2, we can say that here both sides are same, left hand side 1 minus here Q2 upon Q1, in equation 2 T2 upon T1. So we can write Q2 upon Q1 is equal to T2 upon T1. So from this equation we can say that Q1 upon Q2 is equal to T1 upon T2. Right? So by using these two equations of the efficiency, one for cyclic process, second for the Carnot engine, we obtain the ratio of the heat absorbed to the heat released is equal to the temperature of the heat source to the temperature of a heat sink. Expanding this equation in that form, So we can say that the Q1 minus Q2 upon Q2 is equal to T1 minus T2 upon T2. T1 minus T2 upon T2. Clear this? As we expand in this equation, that means in numerator we take the subtraction of the numerator and denominator, both sides. Therefore, Q1 minus Q2 upon Q2 is equal to T1 minus T2 upon T2. Now, inversing this equation, we obtain Q2 upon Q1 minus Q2 is equal to T2 upon T1 minus T2. Now we know that Q2 upon Q1 minus Q2, that is the coefficient of performance. That is the coefficient of performance. But Q2 upon Q1 minus Q2 is called the coefficient of performance. Is called coefficient of performance. It is denoted by alpha. Therefore, alpha is equal to Q2 upon Q1 minus Q2 is equal to T2 upon T1 minus T2. Is the equation of coefficient of performance for a Carnot engine. Is the equation of coefficient of performance of a Carnot engine. Clear this? Very easy to derive this equation. That is important for 2 marks. Obtain the equation of coefficient of performance of a Carnot engine. We start from this. An efficiency of a cyclic process, eta is equal to the n is equal to 1 minus Q2 upon Q1. And the same equation we derive for the Carnot engine, the efficiency n is equal to 1 minus T2 upon T1. That is second equation. Comparing these two equations, we can say that Q2 upon Q1 is equal to T2 upon T1. Inversing it, therefore Q1 upon Q2 is equal to T1 upon T2. Clear this? Okay. Now, expanding this equation, that means we take the difference of the numerator and denominator in numerator. That means our numerator becomes Q1 minus Q2, denominator as it is divided by Q2 is equal to, on right hand side, T1 minus T2 upon T2. Therefore, expanding this, we obtain this equation. Now, take the inverse of this, or the reciprocal of this equation. Therefore, Q2 upon Q1 minus Q2 is equal to T2 upon T1 minus T2. But we know that already we derived the equation of coefficient of performance for a refrigerator, Q2 upon W. So here Q2 upon Q1 minus Q2, that is known as the coefficient of performance denoted by alpha. So we substitute the value of Q2 upon Q1 minus Q2 as alpha. Therefore, alpha is equal to Q2 upon Q1 minus Q2 is equal to T2 upon T1 minus T2. Is the equation of coefficient of performance of a Carnot engine. Right? Okay. Now, next question is that obtain the relation between the coefficient of performance and efficiency of a Carnot engine. So, question is that obtain relation between coefficient of performance and efficiency of the Carnot engine. So that is the most important equation to find out the coefficient of performance from the efficiency, or we can also find out the efficiency of a cyclic process or the Carnot engine if we know the coefficient of performance. Right? Therefore, obtain the relation between the coefficient of performance and efficiency of a Carnot engine. Now we know that the coefficient of performance. From the definition of the coefficient of performance, the total heat absorbed to the total work done. This ratio is known as the coefficient of performance. Again, the ratio of total heat absorbed to the total work done or the net work done on the system, that is known as the coefficient of performance. Therefore, coefficient of performance alpha is equal to Q2 upon W from definition. But we know that W is equal to work done is equal to Q1 minus Q2. Q1 minus Q2. Therefore, we substitute the value of W as Q1 minus Q2. Therefore, Q2 upon Q1 minus Q2. That is our equation number 1. Now, the numerator and denominator of this equation is divided by Q1. Again, the numerator and denominator is divided by the Q1. Therefore, alpha is equal to Q2 upon Q1 and divided by Q1 minus Q2 upon Q. Here the numerator and denominator is divided by Q1. Therefore, this equation can be written as Q2 upon Q1 upon, here Q1 upon Q1 1 minus Q2 upon Q1. Q2 upon Q1. Again, we divided the numerator and denominator by Q1. Therefore, alpha is equal to Q2 upon Q1 divided by Q1 minus Q2 upon Q1. We take the Q1 separately to the each term. Therefore, Q1 upon Q1 1 minus Q2 upon Q1. But we know that 1 minus Q2 upon Q1 is the efficiency of a cyclic process is equal to efficiency of a cyclic process, and that is denoted as N. Therefore, our equation becomes alpha is equal to Q2 upon Q1 upon N. Therefore, Q2 upon Q1 is equal to N alpha. That is our second equation. That is our second equation. Now, 1 minus Q2 upon Q1. Already we discussed about that. That is the efficiency of a cyclic process that is denoted by N. Therefore, we mention as N. Therefore, alpha is equal to Q2 upon Q1 upon N. Take the N in this side. Therefore, value of Q2 upon Q1 is equal to N alpha, equation number 2. Now, efficiency of a Carnot engine based on cyclic process. Based on cyclic process. That is N is equal to 1 minus Q2 upon Q1. 1 minus Q2 upon Q1. Clear this? Okay. So from this equation, Q2 upon Q1 is equal to 1 minus N. Take Q2 upon Q1 this side and this side. Therefore, Q2 upon Q1 is equal to 1 minus N. Equation number 3. Now, left-hand side of equation 2 and 3 are same, Q2 upon Q1. Therefore, comparing equation 2 and 3. So we obtain N alpha is equal to 1 minus N. Therefore, alpha is equal to 1 minus N upon N. 1 minus N upon N is the relation between coefficient of performance and efficiency of a Carnot engine. That means the alpha is equal to 1 minus N upon N. So left hand side is the coefficient of performance, while the right hand side is the efficiency of a Carnot engine. So this equation shows the relation between alpha and N. That means the coefficient of performance and the efficiency of a Carnot engine. Again, obtain the relation between coefficient of performance and efficiency of a Carnot engine. Now we know that the coefficient of performance alpha is equal to Q2 upon W. What is the W? W is equal to Q1 minus Q2. Heat absorbed and heat released. Therefore, alpha is equal to, we substitute the value of W as Q1 minus Q2. Therefore, coefficient of performance alpha is equal to Q2 upon Q1 minus Q2. Right? Dividing the numerator and denominator by Q1. Therefore, alpha is equal to Q2 upon Q1 divided by Q1 minus Q2 upon Q1. Therefore, Q2 upon Q1 is equal to 1 minus Q2 upon Q1. In denominator term, we divided each term of denominator by Q1. Therefore, Q1 upon Q1 then becomes the 1 minus Q2 upon Q1. Clear? Okay. But we know that denominator term 1 minus Q2 upon Q1 is known as the efficiency of a cyclic process. Right? That is the N. Therefore, alpha is equal to Q2 upon Q1 upon N. So from this equation, the value of Q2 upon Q1 is equal to N alpha. So, right, alpha is equal to N times, the Q2 upon Q1 is equal to N times alpha. Now, the efficiency of Carnot engine on the base of cyclic process. Efficiency N is equal to 1 minus T2 upon T1, but already we know that T2 upon T1 is equal to Q2 upon Q1. Therefore, on the base of the cyclic process, the efficiency of a Carnot engine N is equal to 1 minus Q2 upon Q1. So this equation, what is the value of Q2 upon Q1 is 1, take Q2 upon Q1 this side and N in this side. Therefore, Q2 upon Q1 is equal to 1 minus N. Now, equation 2 and equation 3, left hand side are same. Therefore, comparing equations 2 and 3. Therefore, N alpha is equal to 1 minus N. Therefore, alpha is equal to 1 minus N upon N. This equation is the relation between coefficient of performance and efficiency of a Carnot engine. Thus, we obtained the two important equations for the Carnot engine. One is the coefficient of performance of a Carnot engine, and second is the relation between the coefficient of performance and the efficiency of a Carnot engine. The coefficient of performance alpha is equal to T2 upon T1 minus T2. While the efficiency of a Carnot engine is N is equal to 1 minus T2 upon T1. Therefore, the performance, coefficient of performance and efficiency depends on the temperature of the heat source and also the heat sink. Right? Therefore, the Carnot engine is the engine operating between the two temperatures T1 and T2. T1 is the temperature of the heat source and T2 is the temperature of a heat sink. Clear this? Okay. So here, chapter 12, thermodynamics is completed. The last portion is the Carnot engine. We discussed its construction and how it works. And what is the equation of its efficiency, coefficient of performance, and what is the relation between the efficiency and the coefficient of performance of the Cyroid engine. Clear it?